Hello, welcome again to the trigonometry, and today I want us to talk about the sine and cosine rules. There are some more specific rules that we shall often be relying on to solve triangles. The basic ones are the sine and the cosine rules. Let us start with the sine rule. Suppose we have some triangle like this one, and that triangle has both sides. This vertex being A and this one being B and this being C. From what we have learned about the sides of the triangle, then this one becomes B, this one becomes C. If this triangle has got some vertical height and that height is mutual to the base AB, if we name it to be H, let us say H1, you will see that from this small triangle, the left side triangle, the sine of A actually equal to opposite. The opposite of A is H1 and the hypotenuse is B. So the sine of A, you find that it is H1 over B, which means that H1 will basically be equal to B sine A. But when you use this right hand triangle, you see that the sine of B is equal to H1 over A, such that H1 is equal to A sine. If this is H1 and this is H1, it means this is the same height, and we can therefore say that the two are equal. That is, A sine B is equal to B sine of A. You can try to make the dimensions be the numerators and the functions be the denominators. This can be achieved by dividing both sides, for example, by A sine A, so that we cancel, and this way, and this way we say over sine A. Both sides, dividing both sides by sine A cancels this side, and have A over sine A of sine of B becomes equal to B. If we divide again both sides by the sine of B, we realize that this one cancels by that, and we find that A over sine A is actually equal to B over sine of B, and we can say this is fact. Let's name it fact 1. But again, you see that if we constructed another perpendicular height from A, let us say it goes and lands around there, the perpendicular height like this, so that now this is H2. You will see that trying to study the upper triangle, you will see that the sine of C is equal to the opposite of C is actually H2. So it will be equal to H2 over B, which is the hypotenuse of that upper triangle, meaning that H2 is actually equal to B sine C. Again, comparing the lower triangle now, you will see that the sine of B is equal to H2 over C, such that H2 is equal to C sine of B. This is achieved by just was multiplying to get this one. Once again, if we say that H2 is this, and again H2 is this, the implication, or the simple implication, will be that actually, because this is the same H2, it means that B sine C is equal to C sine of B. Likewise, like we did before earlier, you will see that B over sine B actually equals C over sine C. You can call this one be another fact, and let us call it fact 2. Bring fact 1 closer here. which said that also factor 1, don't forget factor 1 said that b over sine b was equal to a over sine a. This was factor 1. By implication, if fact 1 is stating this and fact 2 is stating this, they are saying b over sine b equals c over sine c. b over sine b equals a over sine a. The implication becomes that actually a over sine a is equal to b over sine b, but this one is the same as c over sine c. And this one, this statement here is what we call the sine rule. This rule will be applicable in most cases when you have modeled a triangle. When your challenge makes you model a triangle, and triangle here you realize that you have got some two sides and one angle, or some two angles and one side. When you apply this rule, life will be so easy for you to solve that triangle. Don't forget that solving a triangle means trying to find its angles as well as the lengths of its sides. Now let us try to look at the cosine rule. Suppose you have some triangle. Again, you shall suppose some triangle. Let us again use a triangle there. B, C. By now, we should be all comfortable that this side becomes A, this side becomes C, and this side becomes B. And suppose this triangle has got some perpendicular height H, and you will see that if from A to the perpendicular height is some distance unknown as X, then the remaining part of AB, becomes C minus X. Now this one is easy to see. Then you will see that considering this smaller triangle here on the left side, you will see that b squared minus x squared is equal to h squared from Pythagoras theorem. And you can call this one factor 1. Now, trying again to consider the right hand side triangle, you will see that s squared minus c minus x squared gives us the same height h. That should be also easy to see, and it is another special fact for us to deal with. At this point, from those two facts, if we try to simplify this one by expansion, you will see that a squared minus, we deal with the bracket first, c squared minus 2cx plus x squared is equal to h squared. Opening up the bracket, you will see that a squared minus c squared plus 2cx minus x squared equals h squared. If you try to bring this component which is telling us about h squared and you place it here, where it is h, we put in Roman 1, you will see that a squared minus c squared plus 2cx minus x squared is equal to b squared minus x squared. Try to correct like terms. If you try to move this one and this one, both of them being negative, you see that this can cancel on that one. So that's now what we have is a squared minus c squared plus 2cx is equal to b squared. Trying to take these components here to the right, you find that a squared equals b squared plus c squared minus 2cx. You can call this one another third fact. At this point, we have some component x, which is eliminatable. If we go back here on our triangle and you consider again this small triangle, you will see that the cosine of a is actually equal to adjacent, which is x, over hypotenuse, which is b. And the implication is that actually x is equal to b cos of a. This one being true, if we substitute it into equation 3, you realize that a squared equals b squared plus c squared minus 2c dots. Now we can substitute where there is x, put there b equals a, say b cos of a, because we have seen that this is x, this is the value of x, and therefore the conclusion can come to be that a squared equals b squared plus c squared minus 2bc cos of a, and this is what we call the cosine rule. The cosine rule is stated in 3 ways. If you follow these same procedures after you can try, you will discover later that b squared equals a squared plus c squared minus 2ac cos of b. Please go through the same procedures and ensure that you get this rule or you confirm this rule. It is also that c squared is equal to a squared plus b squared minus 2ab cos of c. That means that for each side you are looking for, you need at least to use one of these rules. If you are looking for c, you use the rule that involves c. If you are looking for b, you use the rule that involves b. And if you are looking for a, you use the rule that involves c. The side for which you are looking for, its angle must have been given. And every time you have modeled a triangle and it gives you these facts, then the cosine rule will go a long way to help you. Now that we know the cosine and the sine rules, can you try to have some examples where we can apply these rules? Example. Let me call this one example 1. Solve the triangle below. Suppose we have modeled some triangle of this nature, and we will say that this angle here is a, b, c, and that this one is 71.6 degrees, and this one is 53, say, let us take 56.3 degrees, and this side is 8 centimeters. By now, all of us must be comfortable that this side is named as C and this is the side named as A because the angle here is A and the angle here is C. From sine rule, it states that A over sine A is equal to B over sine B. We can find this one is now solved by just stating that A over the sine of 71.6, trying to put in the values, find that it is equal to 8 over the sine of 5.6.3, and this is fact. When we try to cross multiply, we find that A is equal to 8 sine 71.6 over the sine of 5.6.3. You can find that when you get your calculator and place it very well. When you get your calculator and you press it very well, find that A actually should be giving 9.124 centimeters. So this one is 9.124 centimeters. Remember that when solving a triangle in trigonometry, you actually try to look for all the sides and angles of the triangle. Now that we know some two sides and we know some two angles, we are named with one angle point and one side point. The remaining angle is angle SCB, and that angle can be got from angle sum principle, which states that A plus B plus C can equal to 180 of a triangle. The implication is that therefore C plus 7 1.6 plus 5.6.3 actually gives 180. When we try to solve that one, we will find that angle C is actually equal to 52.1 degrees. Now this angle here is also known 52.1 degrees. Now we are remaining with tracing the side opposite it. We can still use the sine rule and we say that C over sine 52.1 is equal to 8 over sine 56.3. When you try to solve this, you find that C becomes 8 sine 52.1 over sine 5.6.3. And the answer can be got when you try to place your calculator very well. You must be getting 7.587 centimeters. Ideally, the number of decimal places can be rounded off to 2 decimal places, but the most ideal when dealing with such numbers is to try to make sure that you leave at least three decimal places. Let us try to look at another example. What we have another triangle. You have modeled your other triangle, and this time it looks like this. Suppose it like that one. In that triangle, let us use ABC triangle ABC, and you discover that the lengths that you have measured on your model, they are actually looking at this being 10 centimeters, and this being 7 centimeters, and this being 8 centimeters. When you have a triangle like this, only the sides are given, the angles are not given. Try and test the sine rule, you'll see that it won't help you. But when you try to apply the cosine rule from cosine rule, you find that A squared equals B squared plus C squared minus 2BC cos of A. You'll find that in this one, you only have angle A, which is unknown, the unknown in this equation. And because you have all the others, then you can use this equation to find angle A. So we can say that what A is 8. So 8 squared is equal to 7 squared plus 10 squared minus 2.7.10 cos of A. And when you try to solve this one, you see that this is 8 squared minus 7 squared minus 10 squared. And when you try to make the cosine of A the subject of the formula, I am going to take this one on the left and then bring this one on the right. You see that actually 2.7.10 cos of A is equal to 7 squared plus 10 squared minus 8 squared. And at this point, I can divide both sides by this. Then I say the cosine of A becomes 7 squared plus 10 squared minus 8 squared all over 2 times 7 times 10. And when you conclude here, you use your calculator, press it very well. Make sure you make proper use of the brackets, and you find that the cosine, the angle, and from the calculator, you can take the upper cos, this is the way we write upper cos, or the whole of this one, 7 to plus 10 squared minus 8 squared all over. Down here is 1/4. And the answer we expect you to get, the answer expected to be got will be 1.3 degrees. Please make sure you check and confirm if that is what you actually got. Please check and confirm and see if that's what you actually got. For the others, when you want to get B, you can still use B squared equals A squared plus C squared minus 2AC cos of B, and then use this one again to move through this process here until you are able to get the value of this angle B. That's how we use the cosine and the sine rules. I hope that now we are comfortable with the rules, and you should be comfortable to be applying these trigonometric rules in all challenges that will end up modeling a triangle. If you have liked this presentation, please don't forget to subscribe onto my channel and like it. Just in case you have some comments to make, please feel free to make your comments in the comment section. See you.